Really, the technicality here is to understand that LDLs and HDLs are exactly the same thing. They simply have different densities. There is no good nor bad or any other reason for saying that. And if you want to talk about cholesterol, you have to talk about LDL cholesterol and HDL cholesterol inside of them as the same thing.
Hello and welcome to Castle's Corner. I'm Coach Castle, and I'm here to educate you in the latest science regarding biomechanics, biochemistry, respiratory health, nutrition, and much more. Please remember to subscribe to this channel and like these videos if you find this content helpful. But now, let's go ahead and get into the video.
Hello and welcome to Castle's Corner. I am Coach Castle, and today I'm going to be doing another Mythbusters episode. And in this particular episode, I will be addressing why there is actually no such thing as good or bad cholesterol, in spite of what you've heard, why doctors are wrong about it, and also how they present it, my frustration with the way that it is commonly portrayed on social media and in the press. I'm quite sure that most of you, no doubt, have heard or read quite frequently cholesterol being referred to as either good cholesterol or bad cholesterol. Now, I actually recently go over this in my latest book, 10 Steps to a New You, as cholesterol is extremely important. I think I get into it in step 8. But anyways, it's very important to your health, and understanding it is also very important. Now, I'll be getting into it a little bit later why it's so important, a breakdown as to why there is no good or bad cholesterol. And I will have to get technical, just a few times. Just try to bear with me for a moment or two while I say some, technical things, and then I'll simplify everything down. I just want you guys to have a good understanding as to why there is no good or bad cholesterol. So, before anything else, let's understand what cholesterol actually is. Cholesterol is a lipid, and it is synthesized by every single cell in your body, meaning each and every cell in your body makes cholesterol, at least to a certain degree. The fact that every cell in your body makes cholesterol should tell you a bit about how important it is. Now, just think about when you look at a picture of a cell. They look like these two-dimensional structures, sort of like a somewhat transparent sphere, with some stuff inside. But just understand, cells are actually three-dimensional, of course. They're kind of spherical little bubbles, and although they are very small, they are fluid. Now, for these cells to move through the body, they must be fluid. And the cell membrane, the kind of wall which encompasses a cell, is what provides that fluidity. So just think the outside of the bubble of the cell. And now this is also what allows transporters to go across the surface of cells. And when I say transporters, I am referring to various things like glucose ions and hormones and stuff that needs to transverse throughout the cell membranes. Now, it is very important to understand that if you didn't have any cholesterol, you wouldn't have any cells. And if you didn't have any cells, you wouldn't be here listening to me. So basically, no cholesterol equals no life. Now, cholesterol is a precursor of some of the most important hormones in our body, everything from the production of vitamin D, cholesterol, estrogen, progesterone, testosterone, all these things. And cholesterol is also essential for bile production, or else we would not be able to digest most of our foods, especially fatty foods. It's a very large list as to why cholesterol is essential, but I think you guys get the idea. Cholesterol, which is made, again, in every cell of our body, and each and every cell makes at least enough to meet their individual needs, although some cells actually do make a little bit more. They overproduce to compensate for times of high stress to distribute it throughout the body. Now, for example, there are certain cells that tend to be net exporters of cholesterol. So the liver, for example, as a general rule, it just makes more cholesterol than it needs to. Whereas there are parts of the body that need more cholesterol than they are typically capable of making during periods of high stress. So sleep deprivation or just a massively stressful environment, etc., you will be a little bit deficient in other areas. So these parts of the body will need to have cholesterol delivered from other cells in the body. Now, of course, this only poses a little bit of a problem due to the nature of lipids, or to be more precise, their fatty nature and density. Now, this is because the main channel that we like to use in the body for transportation is, of course, the circulatory system. Now, this is, of course, probably well known to most of you, know about all the veins in the blood and etc. Now, within the circulatory system, the body has no difficulty transporting glucose or electrolytes, lactate, etc. And this is because all of these things are water soluble. Now, of course, the circulatory system is made up of plasma and proteins, and that's what your blood is. However, as previously stated, cholesterol is a lipid. And if you can remember anything from biology, you will know that a lipid is not water soluble. It is, in fact, hydrophobic. Now, so basically just think it's afraid of water and it doesn't mix well. Hydrophobic. Basically, it just means it is not water soluble. So if you were to think about if I had a glass half full of some vegetable oil and then added some colored water to it, the colored water would sink to the bottom and the fat would rise to the top. Now, this is because they are repelling each other. So in short, lipids are not compatible with the circulatory system. And of course, a solution must kind of present itself in order to fix this. So the solution to bypassing the circulatory system is to create a vehicle that is capable of transporting the cholesterol to other areas of the body. Now, this vehicle is called a lipoprotein, and it is basically just wrapping the fatty lipid part in a protein. So the lipid part is on the inside, and the protein part is on the outside. Now, the protein part is water soluble, basically creating a spherical bubble in which you can package the hydrophobic cargo. So now this molecule is free to move throughout the circulatory system, as it is now water soluble, being encased in this fluid bubble. Now, there are a few classifications of these lipoproteins. Some of them are ApoA and ApoB, which are basically lipoproteins that create a larger 3D sphere that wraps around the spherical lipid protein. I like to compare it to a turducken. So in this case, the lipo would be the duck, the protein would be the chicken, and the ApoB would be the turkey. So this layering is what defines the lineage of lipoproteins. And some of these are terms you've probably heard of, such as like VLDL, IDL, LDL, and LP(a). Now, the ApoA lipoproteins form a different class of these, which are known as HDLS. Now, all of these acronyms simply refer to the feature of the lipoprotein that is distinct from the lipoprotein that wraps around them. So, in simple terms, going back to the water and the oil, these are actually a large list of substances which you could pour into that glass, which would give you various different layers to it due to their various densities. So the heavier stuff floats to the top, and the less dense stuff floats to the bottom, and all the various densities in between. So, really easy to understand, the heavier density object relative to the lower density object is going to sink versus float. And this is how you have that layering effect. Now, if you take all of these lipoproteins previously mentioned, and you add a special kind of gel to them in a lab, you can see the separation of them based upon their density. Again, kind of that layering effect that we talked about. Now, the ones of highest density are called HDLs. Now, you do have more than one form of HDL. There are many different subclasses, which are all very complicated and mostly not even fully understood as of yet. Which is why it's very frustrating when people say having a high cholesterol is good. All they are really attempting to say is having a high HDL cholesterol is good. And while it is true that on average, higher HDL cholesterol is associated with greater metabolic health, and low HDL cholesterol tends to go hand in hand with bad metabolic health, this is not conclusively proven, and it is impossible simply by looking at an individual's cholesterol, whether they are healthy or not. And this is because that single snapshot that was just taken of how much cholesterol is in your HDL tells you nothing about the functionality of the HDL, and its functionality is the thing which actually matters the most. Now, to discuss the LDL. This is a lipoprotein that is the low density. So think lipoprotein, low density, referred to as bad cholesterol. So just a reminder, we have on the other side HDL, which is commonly referred to as good cholesterol. So to be really clear, when you go to the doctor and they tell you good cholesterol, they are mistakenly referring to your HDL, or high density lipoproteins. And when they say bad cholesterol, they are referring to LDL, or low density lipoproteins. Now, just a reminder, it is simply high density or low density. There is no good or bad. And when somebody asks you what your HDL is rather, and what your LDL is, they are asking for a laboratory metric, and they are asking incorrectly, as there is no laboratory metric called LDL or HDL. Now, while there is HDL cholesterol and LDL cholesterol, there is and can be represented as HDLP and LDLP in testing. Now, the P simply stands for particle number, which can be counted via electrophoresis or MMR. However, the cholesterol in HDL is no different than the cholesterol in LDL. There is no difference whatsoever. Cholesterol is cholesterol. They simply have different levels of density. Therefore, it is completely inappropriate to say having a high HDL is having a good cholesterol and having a high LDL is having bad cholesterol. The actual truth is that the LDLs themselves are lipoproteins. What they do is simply go into the artery walls where they are oxidized and drop their oxidized contents. Really, the technicality here is to understand that LDLs and HDLs are exactly the same thing. They simply have different densities. There is no good nor bad or any other reason for saying that. And if you want to talk about cholesterol, you have to talk about LDL cholesterol and HDL cholesterol inside of them as the same thing. So again, as I've always said, everyone, use your own brains, do your own research, and come to your own conclusions. The medical establishment, all of these people talking about good, bad cholesterol, they are talking out of their ass. There is zero evidence for anything they are saying in relation to high cholesterol of any form, being good or bad, or low cholesterol of any form being good or bad. Cholesterol is simply cholesterol, which is necessary for your body to use, and every single cell in it produces it and uses it. And of course, you also have to consume external sources of cholesterol, but that's for another video. But anyways, guys, I did want to address the eye patch real quick because I know you're wondering. Long story short, last couple days I had some trouble with my eyes. I had to get a little bit of surgery on it. It's getting better. It's just very light sensitive. So just so you guys know, sorry for the pirate appearance, but work goes on. So anyways, this was the Mythbuster on good versus bad cholesterol. I hope I cleared it up. Any questions, just leave them in the comments or email me as you guys do. Please remember to like, share, comment, and subscribe. And guys, have a wonderful day. Every little bit counts. Don't forget, get your finger exercise in and help me out at the same time. Like, share, comment, and subscribe.